Okay, maybe it's promising a little bit too much, but I am super excited about this. I'm gonna need to do a longer introduction first, and I have to admit that I spent more time working on this than preparing the presentation. I know it's the worst, like when the presenter says, I didn't have time, but like we're gonna see some cool stuff. Just bear with me if things go a little bit wrong. It's all very much unfinished work, but I'm almost there, or I'm sort of there, but I'm not sure like how stable everything is. We'll see. So bear with me. So first we're gonna do some Elm stuff, and we're gonna do some reducer stuff. Well, you now know everything about reducers. So my reducers look a little bit different. I have this state struct, and then the send is sort of my reduce function. Instead of calling it reduce, I call it send. You know, it takes a message, and it's mutating, so it can mutate the state. And in my case, it also returns a command, which we're gonna ignore at first. And then, so a while ago, I started looking into Elm. And Elm is really, really cool. So what they do is very simple. You have a reducer. You send it actions or messages in my case. And then you modify the state depending on those actions, just like you saw before. And then what they add is this idea of a virtual view hierarchy. And that's down below, this view controller computed property. And it's basically saying, like, from the state, I can compute a view controller. And this view controller is going to send back messages. So you can see that the type stated message sort of will match up with the message of the state. So the view controller will send messages, which can then later get dispatched by this kind of, what did you call it, store? I call it driver. So let's run this and see if this works. I hope my computer will keep running and everything will keep working. So you can see here that we're sort of expecting that a view controller will pop out with a label in there, and the label should say hello world, like nothing fancy. Hopefully it'll work. It takes a little while. We'll do less waiting later on, but I just want to show the first version. Oh man, this is really slow. So one thing you can already notice a little bit, I'll talk a little bit over all the launching waiting, is that this is a pure function or a computed property, which is sort of the same thing. It's not, this view controller thing is not going to be mutated. The only way you can get this view hierarchy is a pure function from state to this view controller thing. It's not a UI view controller, but a description of a UI view controller. So we're attaching, we're almost there. And now probably this is going to take a little while, but it's going to show hello world. Yeah. OK. Thank you. OK, so we got the hard part over with. OK, now so this view controller is a description of the view hierarchy. And what do I mean by that? So if we would change the state, this driver thing, or what Brandon called the store, is gonna recompute a completely new view hierarchy, or in our case, a completely new UIKit virtual view hierarchy. And then the driver is gonna look at what's on the screen and see, like, do a diff. So there's some of Jack's code in there. It's gonna do a diff with sort of what's on the screen and what do I want to be on the screen, and it's gonna change the screen just like that. So that sounds very abstract. We're going to make it very concrete. So the first thing I want to do is wrap this view controller inside a navigation controller. So we can say view controller. Oh, actually, let's do something different. No, yeah, we're going to put it in a navigation controller. So we can say view controller dot, and then hopefully we get autocomplete. Navigation controller. And then in here, it wants an array of, well, the name is view controllers, but it wants an array of navigation items. So to put a view controller inside a navigation controller, you have to wrap it in a navigation item. So it's sort of the other way around as in UIKit. But the types will help us, and we just basically have to satisfy the compiler. So we want an array, and then in this array, we need a navigation item. So let's type navigation item, and here we go. Oh, autocomplete was there for a little while. So there's a bunch of parameters. The framework isn't really doesn't really have default parameters. It should have, I just didn't get around to that. So let's say home, and then use no bar button item for that. Now we want to have false here, or actually true, why not? And then we can put the view controller in. And hopefully we can run this. And hopefully, yeah, maybe we need some generic. Oh, this is an array. Maybe we don't need to do generics. Yeah, it seems to work, and it's going to now put it inside a navigation controller. And hopefully it goes a little bit faster with launching. It seems to, okay, so it's going to put it inside a navigation controller. So it's not very different from what we had before, just inside a navigation controller. Now the next thing is to do some kind of state mutation. So now, yeah, you see it's a navigation controller with hello world, super non-exciting. The next thing is mutation. And to do mutation, well, if you remember from Brandon's talk, with a reducer, you have to send an action to mutate it. So how do we do that? Well, we can, for example, send an action from a bar button item. So let's create a bar button item. So we can say bar button item dot, and then hopefully we get the system one, and we'll do the add. And then as the action, the compiler knows we have to send a message. And that's sort of the message that we defined here at the top. So for example, we could say, let's change our state to have like an array of numbers, and then we want to add a random number. So the first thing we're going to do is have some numbers in here. So this is going to be an array of integers. It's just going to be 1, 2, 3. And then we want to have an action. Let's say add random number. And then over here, we can use that action. So we can say add random number. And well, we can run this, and nothing will happen except that we now have this bar button item. But what's really cool is we can use these numbers, so we can use our state within the virtual view hierarchy. And it will automatically, if we change the state, the view hierarchy will automatically re-render. So we now do have a button here once everything launched. And we can click it and nothing happens. We just, yeah, nothing happens, right? And to make something happen, we have to do something with this message. So we switch over the message, and we get this case add random number. It's the only case. Okay, yeah, there we go. And we can say, for example, numbers that append, and then we do an integer of arg for random. And let's divide it by, or do modulo 100, so that we get readable numbers. And now it's going to get super exciting. When I first noticed what happened here, it's at the same time super exciting, and it's like sort of like, yeah, why is this exciting? So let's see what happens. We can press plus. Well, okay, there's one more thing. There's one more thing. We now need to use those numbers. We're appending to the array, so it's kind of cool, but nothing is done with that array. And if we, for example, say numbers, and then do numbers, like just use string interpolation to print all the numbers, whenever we add a number, so whenever the array changes or whenever the state changes, it's going to re-render its entire view hierarchy. It's going to look at what's different from what's on screen. And the only thing it needs to change in this case is the text of the label. So it says 1, 2, 3. If we press plus, it's going to add those numbers there. And notice that we did not set up any kind of binding. We're not observing anything. We're not doing any kind of key value coding to map this. So it's really, that's what's so cool about this being a pure function from the state to the view hierarchy. The system is taking care of this for us. So it is rendering a complete virtual view hierarchy. Whenever a new number is added, it then looks at what's on screen, it makes a diff, and it updates the screen. And yeah, you can do all kinds of cool stuff with this. So we can put the numbers in a table view. So let's do that. So table view is also a view controller of message. And we can say that table view controller, hopefully. Oh yeah, I always make that mistake still. Well, let's see. Autocomplete is always a little bit interesting. So we can again let the types guide us. So it wants a table view, so we just say table view. And hopefully we get an initializer. And this wants an array of cells. So let's do that, an array. And we actually want to take the items, map over them, and turn them into a table view cell. So we can say items.map, and then create a table view cell. And, oh yeah, thank you. So we can create a table view cell. And do we get autocomplete? Not really. Oh, I do need my autocomplete for this one. Yeah, there we go. So for the identity, I'm just going to put in $0, so that's the current number. Ignore that for now. For the text, we want to have some kind of string. So I'll just use a string version of the number, $0. On select, we'll leave nil. On delete, we'll leave nil. And now we can use this. And instead of the view controller over here, we're going to return the table view controller inside the navigation item. So table view controller. And let's see if we can run this. Table view. Build failed still. Oh no. Oh, it did run. There's something weird with my computer, I think, with the screen, that it's very slow. So now we're going to see a table view instead of a normal view controller. So we can add. And notice that we didn't have to set up a data source or anything. It's basically automatically mapping this array to a new virtual view hierarchy, and it's diffing the table view and just inserting those rows and animating those changes. And another thing that you can do, now that we have these two things in place, we can say, well, the view controller is if numbers that count is 0, or if numbers is empty, then we want to return the one view controller. Otherwise, we return the table view. And then over here, we say no numbers yet. And yes, man, I don't think I should be doing this presentation. There's somebody else in there. Yeah, thank you. It's a good thing. So of course we don't see this because we start with an array of 1 to 3, so we never can get to this state. And in order, so yeah, we can add still, but it never shows. So if we start with an initial state over here with an empty array, then we will see it. And then the next challenge is to delete some numbers so that we can go from one state to the other and back. And that also is just very similar to the way we do adding numbers. So it says no numbers yet, and the moment we say plus, it switches to the complete different view controller. Imagine how you would do this without Elm, right? It's quite a bit of work. Now, let's do the deletion, and then we'll go on to talk about the actually exciting stuff because I think this is both very exciting and a bit boring still. So let's add a delete message, and we're going to do it at an integer, so at an index. And now here we need to interpret that message. The compiler will also give us an error if we don't have this case. Now we can just say numbers, remove at index, hopefully. And now here in the onDelete, we can send that message. So we can say .delete index. And the question is, how do we get this index? And I'll just use a quick hack. This is not how we should be doing it, but let's do enumerated .map. And then instead of $0, we're going to say number index, or is it the other way around? Number. It
should be index now.
Yeah, and in. So it's very, this code needs more enters and more new lines. What's that? Delete IDX. Ah. Build field still. Well, let's add a little bit more new lines so we can see what's happening. And let's do it the proper way, because we should have done that the first way around. So we're going to, instead of saying enumerated, we're going to zip numbers and numbers.indices. And then, now I think we get like a tuple in. Isn't it this the new thing? Yeah. Okay, sorry for the messy code. I think we can say let index equals x dot 1, let number equals x dot 0, and then we can delete this and we can say return. Almost. Is it like this? And IDX, yeah. I'm sorry. Oh man. Message.delete, yes. It's very simple, you can see. Okay, here we go, it compiles. So now let's think about what's happening. If we have no numbers, we can put stuff in there, and we can delete stuff. It disappears. And it will go, when we go to 0, hopefully, if we did everything right, it will show the original view controller again. Okay, thank you. So now comes the problem. So I went through the trouble of implementing all this, and I think it's really awesome, but it's not. So first of all, I had to do a lot of work to get this working. If we look at the implementation of all this stuff, I was very proud of myself, but I don't think it's a good idea. Like this is for the table view. Like there's basically a bad version of diffing in there that's not quick checked, right? And like there's all kinds of nasty stuff in here. Like it's hundreds and hundreds and hundreds of lines that are not very understandable. And there's a lot of subtleties there. And just thinking back a bit more, when we added a number, what we did is we said, okay, there's going to be this add action. We add the number to the array of numbers. So far, so good. Then we completely forget what we did. And we re-render the complete virtual view hierarchy. And we know, we just added the one number, right? Like it's just, why do we completely forget what we did? I don't think that's cool. Like that's sort of very inefficient and it doesn't feel right. And there's another problem with this kind of setup. And I think Elm and React have exactly the same problem. I'm not sure, but as far as I know, they don't really have a good story for animation. The only thing you can do is look at, okay, this is my table view, this is my new table view, and I'm going to diff and animate that. But you don't get fine-grained control because you sort of forget what you changed, right? Like it's very hard to animate things in and out, for example, or control your animation or have custom animations. Yet at the same time, it's a super cool approach because you don't need to think about bindings, you don't need to think about updating things. It all sort of happens automatically for you. It's very declarative. So you really, the fact that your view is a pure function of the state is really nice. You can just create a new state, render the view hierarchy, and test that so easily, and like change things so easily. That's like we all know how hard these things are to do in UIKit. You just need a lot more code in your application. So that was sort of the problem, and I was very frustrated. I'm like, well, I see this nice way of doing things, but it's too inefficient, and it's not, I just didn't know what to do. And then I found this thing called incremental programming, And I think it's super cool. There's this library by Yaron Minsky in OCaml or ML, I'm not sure. Well, he works at Jane Street, which is this financial company, and they had something called an incremental DOM. And he has a couple of talks about this library, and I didn't understand much at first, but I knew like this is probably it. So I really wanted to look into that, and luckily, just before my running holiday, I got injured, and I had to stay at home for a week. So I had like a week to implement this. Because I wanted to sort of take some time off, at least of writing the book that I was writing. So I started implementing this, and I did a bunch of implementations, and some of them were not so nice, but now I think I arrived at something cool. And so I was very deep down in this rabbit hole. Like I was implementing this incremental library in order to like do an incremental DOM and sort of have an incremental view hierarchy. So let's see, I hope the playground still works because it breaks sometimes. Let's move over to the next playground. Let's see if it's, ooh. Yeah, it's still working. Okay, so what is incremental programming? So there are a couple of ways to understand it, and I think the coolest or the easiest approach, if you know functional reactive programming, it's sort of similar, but much, much simpler, and it can do much less. So you have inputs, which are sort of like variables in reactive programming, and with the difference that you can only write to an input, you cannot read from it. It's sort of like something you put things in. And then you can have incremental values, so you can say, for example, x dot. You get all the things you can do with x. It's an input, so you can change it, you can write to it, and you can get the incremental value out. So incremental values are basically values wrapped in an I. I don't know about all the naming yet. Somebody can definitely make suggestions later on. I just went with what I liked for now, and it's open for discussion. So I get an I, and then I can observe those I's. So I can say I.observe, and for example, print them. And the first thing that's going to happen is it's going to print immediately. So it's going to print 5, hopefully. Okay, cool. And I can change it, and then it will print again, right? Like that's what we would expect. I write 10, and now it prints 10. Easy enough. What you can also do is combine these incremental values, and there are 2 operations only. So there's map and there's flat map. So map you use to transform, and flat map you use to sort of combine multiple things. So we could say x.I.map plus 1, and then we get basically 6 and 11. Or we could flat map. So let's do that. So we can say x.I flat map. Now we get an int in, and we can return a new I. And so we get, let's say, x value in. And now we can return y.map and say x value plus y value. And to do that, we need also y value in. So this is sort of like a plus operator. Hopefully it'll still work. So this is sort of taking the sum of x and y. Maybe. I don't know if the playground broke. What's that? Yeah, it looks like it. Let me stop this, quit this. This is my life. So now what we did is we read the value of x, and then we read the value of y, and then we added the 2 together. And we should be able to observe the sum if all goes well. It'll start the simulator. Oh, this is very tricky. So we should be able to write the sum. And we can also write this in a different way. I just want to see if it works. Launching simulator. Yes, that's a very good one. Maybe this will help. Yeah, we have to go from the input into the incremental world. Thank you. Well, okay. I don't know why it's not working, so we have to do the backup thing. I can assure you that the code is either correct or almost correct. When I do it on my iMac, it's just fine. Somehow Xcode is a bit broken on this machine. So a different way to write this is x.i.zip and zip with y.i, and then use plus, for example. So this takes the two values and combines them. And it's exactly the same thing. What this does is it creates, basically, you have your x node and your y node, and then when one of them changes, it sends the result to the plus, and then the plus is updated. And so far, it looks a lot like reactive programming, but there's a really big difference. And while Xcode is, I don't know what's happening with Xcode, I'll switch to my slides and show you the big difference. So let's look at these slides. So let's say you do x plus y, and you have to believe me that the flat map and the zip is the same thing. So if you are doing reactive programming, and let's say you change the x, what's going to happen is going to look at all these sort of outward arrows, right? Like all the dependencies of x, everything that's subscribed to x. So it's going to look at this arrow. Then what's going to happen is it's going to look like it triggers the plus, and then it triggers the arrow of the plus. So now this arrow is fired, and you observe the result of the plus, right? Like if you have 5 plus 10, then it prints 15. Easy. In every reactive programming library out there on iOS, this is a problem. If you combine if you define plus as sort of combine the latest values of x and y, but then instead of putting two different values in, you put the same value in, what's going to happen in a reactive, in every reactive library is the x triggers the plus, and it gets 1/2 of the value. It then triggers the sum, and next x goes to its next outgoing arrow. So the second arrow triggers the plus again, and then you get the real sum. And this effect is called flickering. And every reactive programming library on iOS that I'm aware of has this problem. And the problem is because they're dealing with sort of streams of changes, and they're not really built for changing values. And I'll show you what incremental does. So incremental has a queue. This is the queue, a little box. And now when I change x, it's going to put both of those arrows in the queue. So there are now 2 arrows in the queue, both outgoing arrows in the queue. And then it looks at which arrow is sort of higher up. So these two have sort of the same height. If you look from the bottom up, they both have a height of 2. Now, it's going to pick the one that's highest from the queue. So it's sort of like a priority queue. It's going to pick the arrow with the highest arrow. Well, these are the same, so it doesn't really matter. Let's say it picks the first one. Now, it propagates the first arrow, and then the plus gets triggered. And now all the observers of plus get added. So in other words, all the arrows of plus get added. The other one is still in a queue. So now the queue contains 2 things. It contains that first arrow going out from x, and it goes the arrow going out from plus. And it again processes them like it says, OK, I want the highest one. And that's now the outgoing arrow from x. So it updates the plus. Now plus has the 2 correct values, the values that it should have. And then finally it processes the outgoing arrow. And this is the simplest graph that you can construct, which breaks Rx Swift, reactive Swift, all these things. They all break, or well, I think they break. because they have these intermittent values, which is super annoying sometimes, right? Let's say you do a map over the result of this operation and you want to check if the outcome is even, and only when it's odd you animate. Now, if you do 5 plus 5, then you get 10 out, and then you change the x to, I don't know, 6. Now the first arrow will update, it will be 5 plus 6, and then it will be 6 plus 6. So intermediately, it was very quickly odd. And if you animate on those kind of things, then you have all kinds of weird stuff going on in your app. Usually it's not a problem, but it is a theoretical problem, and it makes that you cannot reason about your reactive programs anymore. And that's why it's always so confusing to newcomers. You have combine latest, you have zip, you have flat map latest, you have take distinct until changed. All that stuff doesn't happen here. So that was sort of the infrastructure. This is very simple infrastructure that I needed, or not so simple maybe, but it's infrastructure that I needed to build an incremental DOM. And well, I don't think the playground is going to work anymore, so I'm going to switch to a simple reducer-based example. I was expecting it would break at some point. So I'm going to launch this reducers example, and we can look at the code a little bit. It's over here. This is a simple currency converter. So over here, I have my state. It has some input text, a rate, a currency. It has some messages, just like we saw before. It has some commands, and in this send method. And for example, when the reload button gets pressed, we load some data from the network, and it sends the data received message back. This is all sort of straightforward reducers. Then the exciting part is over here. This is an incremental view hierarchy. So it's almost like what we saw in Elm, but without any of the diffing. So here, every view is incremental. So for example, this line 107, you can see that the text field has the input text. That's an incremental text. You can see on line 112 that we define the background color of the output label to be dependent on the input amount. So it's an incremental background color, an incremental UI color. And we can put this stuff into stack views and like create this view hierarchy. And what we get out is like, here we have our little calculator app. It has no conversion rate loaded, so it says ... Once we press reload, a network request will fire, and then it will automatically update the exchange rate. And we can go in here into this input field, which is beautifully styled. If we type things, like it'll incrementally update our entire view hierarchy. So this works just like Elm, except without the diffing. It's just regular UI views behind the scenes. And if we press like a non-number in here, it'll change the background color. So you define it in exactly the same way. And I'll show one more app, and then we'll call it a day. This is also an interesting story. So this is a huge maps, or no, it's a tiny app that works with maps, and it shows all kinds of running trails in my area where I live. And it's all built with incremental programming. So all of the changes and all of the stuff is incremental. And during the Apple keynote last week, I set to improve this app, and I wanted to take, like, because all this incremental stuff feels like a little bit expensive, right? To do everything in sort of incrementally reactive ways. I set to improve the performance, and because it's really slow, like I will show how slow it is. So now it's loading. This is something I can still improve, but we'll see all the running tracks rendered on the map. And well, this should go really fast, right? Now it's going to render all the tracks, and then we can select a track, and like some information, like an elevation profile, will pop up. So here are the tracks. There is a map view behind this. I can select a track, and it will animate in something from the bottom. This is all done incrementally. I can change to a different kind of map, and then this will change the background color of that visual effect view. And like you can see, this is super, super slow. So I thought it was my library. It turns out it's the simulator and map kit. I couldn't find my library in the profiling. So yeah, I think it's super exciting. I don't really know yet where this will break. But to me, like, it feels like a lot of things I've been working towards and like the whole community has been working towards, like with reducers and Elm, is sort of coming together. And this feels like a doable way to do incremental UI kit programming and to take the ideas from Elm and write, instead of like writing a pure function, we write an incremental function. And I think this could be like a different way to build large apps. I was very surprised that everything that I tried just worked. I'm sure I will hit things that won't, but until then, this seems to be really cool. And yeah, my goal for today is basically to inspire you and hope that you will be interested and play around with this. And that's all I wanted to say. Thank you. And I'm happy to take a few questions. So yeah, if there are any. Yes?
So the end effect of this, the end node of your incremental framework is the property itself, not the UI view. So do you recreate a label, a new label every time you set a new text, or do you really set the text property?
It's a good question. So the end result is something, you can see it over here in the type. It's an iBox. And an iBox is really, really simple. So it's a box. Let's see if we can open it up. It's a box. It has this V. So that would be the UI view or the UI view controller or anything you would want to put in there. And it has a bunch of disposables. That's it. That's all there is to it. Now, what you can do is you can say, if I have an incremental value of A, I can, and a key path from my boxed value, for example, from my UI view, and the key path has A as sort of its result. You can sort of bind the two together. It's one-way binding, so it binds anytime the IA changes, it updates that property. So if we look at how label is defined, let's see. No, not over here. Here we go. This is the exciting folder. Let's look at label. So I create an iBox with a UI label. And then I bind the text incremental value to the dot text. I bind, and here the text color is a little bit different. I need to do observing. What's also exciting is the button. So over here, you cannot really bind to title. So here I just say, well, whenever the title changes, just set the title. And all of these wrappers are super simple to write. There's no magic. You just have this one iBox layer around it. And so you build up this iBox with a UI view controller, and then you add the subview to it, which sort of adds that references through the disposables. Once you understand it, it's super simple, really. It might take a while to understand, as with many functional things. But yeah.
How would more complex things do? Like, let's say when you switch the mode, if you like relay out something or like some components would stay, can you combine both approaches? Like
Yeah.
the key with the incremental?
Yeah. So you could, for example, one thing I have here in my playground, which I was going to show but didn't work, is incremental stack views. So maybe magically it will work now. Could be. So there I have. Whoa! It works. Okay, so this is cool. I'm happy. So I start with an array with history. This is an incremental array. The name is bad, but it's just my working title for now. I have an array with history, and then I have an incremental condition for a filter that I use. So here I say, okay, I take my incremental array, I filter it, then I sort it. Here I have an incremental background color, and then I map over the filtered, sort of the filtered sorted array, create a label out of it. I create a stack view, and here is where I bind arranged subviews. So the arranged subviews sort of listens to this incremental array. Now, what we can do is, I'll comment this out for now, and hopefully it'll re-render. So it'll render, at first it'll just render the stack view. Maybe. It's broken again. I can walk you through the code until the playground shows up. So it renders the stack view. Then after 3 seconds, I say insert 4 into the array. And it'll insert 4 and animate that one change, because it knows only that one thing happened. Then I change the condition to only include even numbers. And it will know that it has to sort of filter out these odd numbers, and it'll animate those changes. And over here, I write the background color, and it animates the background color. And all these things just seem to work. Let's see if the table view wants, if this one works. Yeah, it's going to insert 5. It's changed the condition, so less elements. And now it changes the sort order, so it's swapped around. And this is how you do those changes. You insert, you write the condition, and you write the sort order. So and it incrementally knows exactly what to change. It's not going to recompute everything. Yeah, and if you need like very custom animations, that's for example over here. Let's see. Motion ended. This is nice. Yeah, here's a whole bunch of stuff where these polygons that you showed on the map are completely incremental, and it'll animates and updates automatically, and you don't really need to think about it. For anybody who wants to, I can show the actual app. It's super fast on device. It's just really slow in the simulator. Any more questions? Sorry for the long answer. Yes?
How do you define the layout? Is it auto layout? Or?
Yeah, there is no layout thing built in, but yeah, you can do whatever you want. It's not built in, but I had this, I came up with a neat trick for doing the layout, and you can see it over here. So when you create a new view controller, this is like putting a box around the UI view controller. Then you pass in a root view, and the way the view controller's view relates to the root view. And this is just a wraparound auto layout constraint. So equal top is a function which still takes 2 views and makes the tops equal. So that's over here. So I'm saying a constraint is basically a function that takes a parent and a child and returns the layout constraint. So equal top says, if you give me an offset, I'm going to return you a function which still gets the parent and the child, and then it creates a constraint. And then view controller.swift just adds those constraints. So you pass it a root view here and some constraints, and then it just loops over those constraints and sort of relates the view controller's view to the other view. And that's just a simple way to do declarative auto layout without, I didn't want to pull in a big library, but yeah. Yes?
How do you write or articulate sometimes, for example, when you change the sort order, it changes, it basically changes, and sometimes you just do it without the animation. You have to provide 2 separate incremental boxes for the same property.
You mean like in the one case you want to have a table view and you change the sort order and you want to do like a reload?
Yes.
It's a good question. I don't have an answer yet. I need to think a little bit about it. Yeah. Yeah, I guess with a different box it's super easy, but I don't know if there's a better answer than that. Yeah. Oh, and one more thing before I forget. So you can use this virtual view hierarchy stuff also with reactive programming. You don't need to use incremental programming. I think the same technique could be used with a reactive library. It's just a little bit different, but yeah. Yeah, yeah. So yeah, so the reason, so it's just a really elaborate way of building this app, and this app is for a thing called Laufpark Stechlin. It's this running trail network, and if you go to my GitHub, you will find the one repository with the weird name, Laufpark Stechlin, and that's in there. And I'm sort of using this as my mono repo to build incremental and build what I need. Like one thing I really want here is like a table view where you can filter all the trails by distance, and that's why I went all the way and like built this array with history that you can filter and sort, because I need it for the table view. Yeah, so all of this code is exactly, this is just a simple clone of the repo. Yeah. Okay.